Alright, another partial fraction integration problem. This one is integral numerator 16x cubed, denominator 4x squared minus 4x plus 1 dx. So we ask ourselves question first, is this a proper fraction? The numerator has a degree of 3, the denominator has a degree of 2, so it is not proper. So the best thing we can do here is do some polynomial division. So 4x squared minus 4x plus 1. We're going to divide that into 16x cubed, and let's go ahead and put every descending power after that. So plus 0x squared plus 0x plus 0. Alright, so 4x squared goes into 16x cubed 4x times. Multiply that back. We'll have 16x cubed minus 16x squared plus 4x let's double check there. Yep, so then when it comes down we will have 16x squared minus 4x plus 0. And what do you know? 4x squared will go into 16x squared. So let's see. That will go in 4 times. So 4x plus 4. So we'll multiply back. That'll give me 16x squared minus 16x plus 4. Subtract off, doing this old polynomial division. So we'll have 16 minus 4, so that'll be 12x and minus 4. So lots of things can go wrong here. Just kind of glancing at it for a moment. I guess I feel okay. So let's see here. Back up top. Our 16x cubed fraction has turned into a quotient of 4x plus 4. We love that. We know how to integrate that. There's no worry. But then we have plus the remaining fraction. The remainder is 12x minus 4. And the denominator was the divisor, the original denominator, 4x squared minus 4x plus 1. Okay, so now we have a proper fraction to work with, but we do need to see if we can factor it at all. So I think we can. I'm just going to write down what I think it is and then think through and see if I'm right. But don't forget about the 4x plus 4. 12x minus 4 up top. I think this bottom goes to 2x minus 1 times 2x minus 1. So let's see, that was going to be 4x squared minus 4x plus 1. Yes. So it does factor this way. And look at it, it is a repeating factor in the denominator, so that will be important as we move forward. So let's just slide over. Where are we having trouble sliding? Oh, we slid over way much, didn't we? Okay. This is all we really need right now. So let's see here. Let's work on our partial fraction part. So that's going to be 12x minus 4 over 2x minus 1 squared. So what do we need? We need a fraction with denominator 2x minus 1. And since it's repeated, we need a second fraction with denominator 2x minus 1 squared. So what kind of numerators do I need? 2x minus 1 is to the first power, so I need a smaller power up top, so that'll just be a. And with the repeating power, I use the same type, so just a single constant. It's a new constant, so it'll be b. So my two partial fractions are a over 2x minus 1 and b over 2x minus 1 quantity squared. So let's multiply this out so we can figure out what a and b is. So we'll multiply every fraction by 2x minus 1 quantity squared. And hopefully that doesn't give us anything bad. We know on the right hand side everything cancels out and leaves us with 12x minus 4. On the right hand side, we lose a 2x minus 1 out of the first fraction, so that leaves us a times 2x minus 1. We'll call this 2ax minus a. And then the last fraction, we can cancel out the whole denominator part, so we just get a plus b. So we're pretty happy again, just an a and a b, not too many terms here. So let's see if we can do this without losing too much information above. So my x terms, there's 12 x's on the left, and there are 2a on the right. Let's just go ahead and say that means that a is 6. But let's mark where that comes from. I think we're waiting on our computer to catch up here. There we go. And then we'll go for the constant, which has a negative 4 on the left and a minus a plus b on the right. We already know that a is 6, so negative 6 plus b equals negative 4, so I think that means b equals 2. So 2 minus 6 is negative 4, yes. So I have my terms. So let's see what we can do. Okay, I'm going to write down here so I can capture everything, but now we're trying to integrate. Nope, we don't want that color. Now we're trying to integrate the 4x plus 4 that was the quotient of our polynomial division, and then our two partial fractions, so plus 6 over 2x minus 1, and then plus 2 over 2x minus 1 quantity squared. So now I've got where I can see it, I'm going to write it a little bit bigger and space it out so we can work with it. So hopefully everything's in the right place. So we got the integral of 4x plus 4. I feel good about that. Let's just go ahead and separate these, plus the integral of 6 over 2x minus 1. That's going to be a natural log integration, but we do need a u substitution for an adjustment, and then plus a integral of 2 over 2x minus 1 squared. I think that's just going to be a regular u substitution. So let's try and pull things down. So 4x plus 4, that integrates to be 2x squared plus 4x. As I said, this 6 over 2x minus 1, that'll be a u sub. I usually write them out if they're not perfect. So u equals 2x minus 1, du equals 2 dx, so 1/2 du equals dx. So I'm really integrating 1/2 times 6 times 1 over u. So that gives me 3 natural log of u. So since u was 2x minus 1, we have plus 3 natural log of 2x minus 1. Okay, and then the last part, 2 over 2x minus 1 quantity squared. That's another u sub. So u equals 2x minus 1, du equals 2 dx. That's a lot better actually. So this is 1 over u squared du. That's the integral of negative u to the negative 2 du, which is negative u to the negative 1. So we'll rewrite that as negative, from negative in front, and u to negative 1, so that'll be 1 over 2x minus 1 for the u, and then a plus c at the end. So sliding down here just a little bit, so we can draw a little box around our answer. 2x squared plus 4x plus 3 times the natural log of 2x minus 1, and then minus 1 over 2x minus 1, and don't forget that plus c. Good job.